So the next topic we are going to cover under quadratic equations and inequations is the concept of a rational function and inequations. So what is a rational function? So rational function f(x) of a variable x which belongs to the set of real numbers is defined as the ratio of two polynomials px and q of x such that q of x which appears in the denominator is not equal to 0, because then the rational function would be undefined. So the general form is f(x) equals p of x over q of x, and then q of x is not equal to 0 and x belongs to the set of real numbers minus whatever makes q of x 0. So for example, you could have f of x equals x squared minus 6x plus 2 over x squared plus 4x plus 4. So in this case x cannot be minus 2, because otherwise the denominator would be 0 and the rational function would be undefined. You could have gx equals 4 minus x divided by x squared minus 5x plus 6. So in this case x cannot be 2 or 3, because otherwise the denominator is 0 and this g of x would become undefined. So these are two examples of the rational functions. Then we can talk about the maximum and minimum values of this rational function. So maximum and minimum values of a rational function. So we know that f(x) is the ratio of two polynomial functions. It is px over qx. So then let y equals f(x) equals px over qx. And now we are going to be considering the rational function of or the ratio of two different quadratic polynomials. So for example, say, just to illustrate, we take ax squared plus bx plus c and px squared plus qx plus r, where of course a not equal to 0 and p not equal to 0, and also all these 6 numbers a, b and c and p, q and r, they belong to the set of real numbers. So to illustrate the maximum and minimum values of a rational function, I have taken the ratio of two quadratic polynomials to obtain a rational function f(x). So now you know that y equals this ratio. So there, and we also know that this denominator is always well defined. It is never 0, because otherwise the function y is undefined. So therefore we can multiply both sides by the denominator, which would mean that y times px squared plus qx plus r would be equal to ax squared plus bx plus c. So this would mean that py minus a times x squared plus qy minus b times x plus ry minus c would have to be equal to 0. So we know that this equation has to be true if y equals f(x) is the ratio of these two quadratic polynomials. And because we know that x is real, so because x belongs to the set of real numbers, the discriminant of this equation should be positive. the discriminant d should be greater than or equal to 0, and this leads us to an inequality. So this would give you an inequality in y, and on solving this inequality you would be having two bounds on the values of y. So you could have a minimum value of y below which y can never be, so that x is real, and you would have a maximum value of y beyond which y can never be, so that x is real. So this is how you can determine the minimum and maximum values of a rational function, which is the ratio of two quadratic polynomials. So let's do a few solved examples here. So the first example is find the range of the rational function f(x) equals x plus 2 over x squared plus 5, given that x belongs to a set of real numbers. So as we had just discussed, let y equals x plus 2 over x squared plus 5. In that case, y times x squared plus 5 times y would be equal to x plus 2, or y times x squared minus x plus 5y minus 2 would be equal to 0. And we know that x is a real number. So for x to be real and x to also be a solution of this quadratic equation, we know that the discriminant d should be greater than or equal to 0. So what is d here? So d is b squared minus 4ac. So minus 1 squared minus 4 times y, which is a, times 5y minus 2. So this is 1 minus 20y squared plus 8y. So 1 minus 20y squared plus 8y. So this we know has to be greater than or equal to 0, which implies 20y squared minus 8y minus 1 should be less than or equal to 0. And this polynomial or this quadratic equation, you can either get the roots by using the quadratic formula minus b plus minus square root of d over 2a for this particular equation, or in this particular case you can also use factorization, as I'll be doing here. So you can split this sum 8y or you can write 8y as the sum of minus 10y and 2y, because the product of minus 10 and 2 is minus 20, which is what is the product of 20 and minus 1. So minus 10y plus 2y minus 1 is less than or equal to 0. So this means that 10y, 2y minus 1 plus 1 times 2y minus 1 is less than or equal to 0. So this would mean that 10y plus 1 times 2y minus 1 is less than or equal to 0. So you can take 10 out of the first bracket and 2 out of the second bracket, so that 20 times y plus 1 over 10 and y minus half less than or equal to 0. So if you just look at this part, so and look at the roots of this equation, they are minus 1 over 10 and half. And we also know that for this part the a is greater than 0, so the coefficient of y squared is greater than 0. So the parabola must open upward. So the parabola looks like this, and also it has two roots, so they should intersect the x-axis at 2 points. So the 2 points where intersects is y equals minus 1 over 10 and y equals half. And we want this expression which we have plotted here to be less than or equal to 0. And by looking at this, we can conclude that in this case y must lie between minus 1 over 10 and half. So therefore the range of y equals f(x) equals x plus 2 over x squared plus 5 for x belongs to the set of real numbers is minus 10 to half. The minimum value of f of x is minus 1 over 10 and the maximum value of f of x is half.